Before we proceed to look at the code example, here is a brief recap of the difference between creation of processes and creation of threads. When a process calls fork, a new copy of the process is created, and this new process will be scheduled and execute independent of the creating process. As shown in this figure, if the process P, the parent process, calls fork n times, then you are going to have n new processes formed. All of them would be the child process of this parent process, and all of them are independent processes which will be scheduled just like other processes. On the other hand, if you have multiple threads inside a process, every process starts with just one thread, and this main thread is then going to cause formation of additional threads. Now, shown in this figure, it is possible to have multiple threads inside a process, and I have drawn all these squiggly lines inside the circle to indicate this property of threads. Threads are going to share a lot of things among themselves, and things which belong to the process. For example, global variables inside a process are visible to all threads. Open file descriptors, signal handlers, current directory state, and a lot of other things are accessible to all threads. And when I say accessible, it means that all threads can modify a global variable. Just to remind you that in the absence of multi-threading, every process has a single thread, a single flow of execution. But when we have multiple threads, you have multiple functions running in parallel inside the same process. Focus on this point. You have two or more than two blocks of code executing in parallel, and these two parallelly executing blocks of code could go after the same set of variables. What this means is that all of the synchronization problems that you are familiar with that exist only between processes, they also exist when two or more threads try to go after shared resources.